Hello, and welcome to our video where we investigate this particular circuit. So in this video, I will try to talk about this circuit regime over here, and we will try to find out 8 different transmission line equations. And if we investigate this one, we are creating a relation between our book, the chapter 11.3 transmission line equations part, and in this part we are seeing this circuit model, and the first thing that we should do is investigate this one, and after the investigation we will try to end up with 8 different equations like I said in the beginning. So and if we let's try right away, let's not waste time, and if we try to investigate this one, we see these particular inputs from the left side, I and V. We are this is a current and this is a voltage over here we have, but at the rightmost side we are seeing this different I'm sorry, let me draw like this, different current and voltage equations. Actually, if we see this, only this delta Z is making the difference, but let's see why. So for transmission line chapter, we are investigating a very long, particularly like say it's an infinitely long transmission line. And let's call this place for x1, and this is x2. And for x1 and x2, the difference is, let's assume, is a very huge one. So for huge length differences, we are seeing that if we are sending a particular current, we don't see the same current even if we don't have any resistance or any other typical devices in here. So it's not the same current goes in and goes out at the end. It is because the length of what always may be called different effects. But in this particular problem, we are not getting our head with these details, but we simply investigate a small line, small area, small length difference in here. The red line I just did, and we call the difference between this point and this point as delta Z. All right, and this is why we see this I ZT, VZT, but IZ plus delta ZT, VZ plus delta ZT. It is why we see this difference in here. And if we investigate this particular example, we need to start with an Kirchhoff's voltage law equation and KVL equation. Why we start with KVL equation? And you can start with any particular approach you can use. It's not restricted to one approach actually, but the reason why we do is that we are going to see a similar approaches by different approaches as well. So for example, if we are going to draw an KVL equation, we see that it is also related with a KCL equation, and it goes on and goes on. Let's try to find out these relations. It is really fun and easy to do it. So let's start with the KVL equation. All right. In order to start with KVL equation, we have to find a route to follow our needings. And if we try to find the route, we can simply draw an equation like this, and or maybe better one. Let me draw better. What about this one? Yeah, it is actually more looking good. So let's redraw this to blue then. All right, if we follow this blue path, and we are seeing 4 different components right here. And let me erase this part and erase this part so I can show the components much more clearly. And at first, we are starting with this V, ZT, then it is followed by this particular resistance and inductance, and this whole area, it is also included right here. So let's try to see how we done it. We see this that the signs can be approached like this, minus to the plus. So when we follow the blue line, we see this minus VZT. Minus VZT plus R times delta Z, but remember that for the Kirchhoff's voltage equations, we need R and I in order to get V. From the Ohm's law, we remember that V equals to I times R. It is why for this particular voltage in here, I didn't wrote anything but just V. But for this one, for resistance, we need also I in here. And the resistance is also shown by delta Z in here. So here is why I need to R times delta Z times I ZT over here. So let's write it. R times delta Z times I ZT. Great. Plus. Same thing goes for the L delta Z, and if we do this one, we draw L times delta Z times, but let's remember that for voltage equations, we are not using L times I, but not this one, but L times di dt. From circuit 1, we should remember this one. So this is why we write di dt. But it is more helpful to say IZT and delta t, because we have two different components. We should write del, not d, and IZ and t combined with those two. And at last, this one is finished also. And at last, we have this whole red area. So we are looking for voltage difference between here and here, right? This black one. And in order to achieve this, actually, we don't need to investigate one by one like these two ones. What do we do? Let me clean up those one first. Very quickly. All right, what do we do? Actually, rather than going this route for different currents and try to understand the relation between this and this, we just simply say that this voltage difference between this point and this point is also equal with voltage difference between this point and this point, and also between this point and this point. You see, we have the same lines over here, and this place and this place can be shown by the same approach, which is V Z plus delta Z T. This place, this one to this one, this same with this one, this equation, this parameter. So, but why can't we do with like this and this in here? Actually, because this voltage in here is not the same with this one. And let me go with the red one this here. This red V is not same with this green T, green voltage. And also the black one is not same with the red one also, because we are seeing different resistance and inductance. The voltage is changing over here, and this is V Z to T over here. You see? So it is, I think, much more clear, and we just simply say V time V Z plus delta Z T. V Z plus delta Z T. All right, great. And this whole equation equals to 0 because we complete the whole root over here, and the whole root is going back to the same place. This, this particular place we are getting with at the end. So we started from here, we follow the whole line in here, then we end up with the same one. This is why we call this block dot as our reference point, and if we return to the reference point, it is 0 to what we achieve, and it is what we see. So if we rewrite this equation and get this particular particular voltage parameters to left side of the equation, you see something like this. And sorry, V Z T, let me draw it. All right, Z T minus V Z plus delta Z T, and this is equals to, still what remains, let's write it more fast way, IZT plus L times delta Z del IZT del T. All right, it's great to see actually. And okay, we see a particular problem in here, and it is this delta Z's. Actually, we don't want this delta Z in the right side, and we are going to see why we do this actually. But let's get rid of this first, and if let's see what we are going to achieve at the end. And V Z T minus V Z plus delta Z T divided by Z delta Z. We're dividing both sides when we try to get rid of these delta Z's, right? So this whole, let me go with the red one, this whole part is divided by delta Z, and at the same time this whole one also divided by delta Z, right? Let's see what we seen right here, and if we divide this by delta Z, 1 over delta Z, he said that this one and this one is we get rid of these two different delta Z's, and what will remain is that R times I Z T plus L times del I Z T divided by del T. Right, great. Actually, we come this far, but we have one different thing to do. So if we take a close look to this part, actually we have to see this, that if we change the order of minus in here, and sorry, where is this particular one? Yeah, if we change the order of the writing this in here, like changing the minus sign, let's see what we are going to see. Minus V, yeah, minus V Z plus delta Z T minus V Z T divided by delta Z, and the rest of the equation is same. Let me go quickly by this one. Great. All right. So we see this one that this particular term equals to delta V zt by delta z from, which we should remember from the differential equations and or the math 119 and 120 120 courses from our university, and we know this is a differential. So if we rewrite this new equation, we also remain this minus sign in here. We shouldn't forget this one. All right, minus delta V zt delta z equals to r times I zt plus L times del I zt divided by delta t. And this is the first equation we need to get. And yeah, we done our things for the KVL. We have completed KVL equation part. All right, so what is remained? Let's go with the KCL right now. KCL equation. Okay, let's see what we can do with the KCL equation right here. Let me clean up this board again. And let's try to investigate one more time. So if you take a close look for the circuit over here, we see that actually we have this line, and this line over here. Or in order to make it more simple and realistic, we should redraw this like this one, and this is like this. It doesn't matter whether you choose this arrow from left to right or up to down. You can simply do this or like this. It doesn't even matter actually, but I want to make it more realistic, and at the end I don't want to try to find the right equation, the minus equations. I don't want to deal with them. So this is because we go for more realistic way from left to right and down. So okay, and it should ring a bell that for the KCL equation, we were dealing with one particular current in here and one particular current in here, one particular current in here. We know this one also. You can see the same approach in here. We know this one. This one line is serial connected with this resistor and inductance over here. And we notice that the current doesn't change. Current doesn't change on the same line. So, and at the end, we have this IZT. And for the end, we have this particular current over here. What is this? It is the I, Z plus delta Z, and T. And for the lowest one, we follow this path, and we follow this path, and it started with I3. But at the end, they combine again, and we still get I3 over here. Only this particular area is dividing this I3 in the different position, but from the beginning to the end, we see the same I3. So it is one of the things we need to be careful about. And let's also remind you that I1 is particularly equivalent with this IZT over here, and I2 is IZ plus IZ plus delta Z T. So it is why we can investigate this solution for KVCL solution. And let's go with it. Let's say I1 equals to I2 plus I3. Why? Because I1 was like this, I1, and it is taking different paths between I2 and I3. And I1 is sum up of these two roots. See? Alright. Let's go on. For I1, let's remind that I1 is I ZT, I2 is this, and we will come back to I3. And I1 is I ZT, I2 is IZ plus delta Z T. And let's go for I3 again. I3 is combining these two capacitor and conductance. And we don't know the particular currents over here. Let me clean up this one. Okay. We don't know what is the amount of current we see this one. We see it here or here. Let's call it IY and let's call it IX. We don't know what IX, IY is, but we are sure that IX plus IY is, pardon me, IX plus IY is I3. Yeah, sure of this one, but we don't know the particular amount of these ones. So what we can do, we can use this voltage and relate it with this voltage with these two different components over here. So if we do this one, we see that G times delta Z times V Z plus delta Z T and plus we see that C also we also see that C times dV dt over here. Let's remind this one also from the circuit theory. So C times delta Z dV Z plus delta Z T and delta T. Great. And we can see that this particular equation is looking very like this one. You see, for the KVL equation, it's very similar, but with different parameters I, G, and C. Just the difference is the terms. But we can follow the same approach in here, and if we take this I to the left side, we can see this minus I Z plus delta Z T plus I times ZT equals to G times delta Z VZ plus delta Z T plus C times delta Z times delta V Z plus delta Z T divided by delta T. So, and we have to get rid of these delta Z's again. So how do we do that? How do we do that? Actually, dividing both sides with, with 1 over delta Z. For this one, also 1 over delta Z. So if we divide both one like this, we see that I minus I Z, Z plus, Z plus delta Z T plus I Z T delta z equals to g times vz plus delta z t plus c times delta z delta v z plus delta z t delta t. I believe I missed one of the needing is in here. This particular approach, we done it in here. This one I'm talking about. Let me shade it like this. This is for when actually this is equals to this part when delta z goes to 0. All right. Sorry, I missed that part. And let me go with the new equation also like this. And for this particular question also, and if we take this one again, also let's rewrite this one and change the minus sign over here. We see this that minus I times iz plus delta z t plus, sorry, minus this time, iz t and delta z. The right part is completely same. See. All right, great. And we know that this particular one, when z delta z goes to 0 is equal with del I z t delta z. So we have this del I z t del z. And the right side we have g times, but this time delta z goes to 0. So this is also means that this delta z is 0 also. V z t plus I'm so sorry, I also forgot to erase this one after dividing with both 1 over delta z in here. I had to get rid of it this one, but a simple mistake. So c times del v z t del t. All right, great. And let's not forget this minus sign over here. And we see that the KCF equation part is done. All right. We got these both KVL and KCL equations, and actually we are going very great. And all right, let's also go for the further of the question. And remember from our lectures, we know this for del plus del t, it is equal to j times omega. And if we use this one, for both KVL and KCL equation, this is for also equation number 2. Let's fetch the equation number 1 again from here. Let's copy this one. Sorry. All right, let's do this. Great. And also equation number 2. Copy. So remember that the up one, the upper equation, is gathered from KVL, and the lower one is gathered from KCL equation. All right. So if we apply this information on both equation, actually we see something like this. This part becomes j omega, and this part becomes j omega, as we can see from here. And if we rearrange the problem and simplify it, we see that for the new KVL, this one was KVL. New KVL is something like this: del Vs divided by del Z, and it is equal to R plus, and this currents should they are in common for both R and L. So we take these i's these currents out of the parentheses, and we see that they are in common. That is why we only use R and L and this new j omega here. Remember, del over del t was j omega, and L times j omega is our new approach. See, and out of the parentheses, you see that is remained. You can simply go back to same operation if you distribute is on R and L times j omega. You see, we go to the same approach in here. And don't make you confused. You can also think like this one also for pre-step for this one, for this particular problem. So L times j omega I z t, we have R times I z t. This I z t and this I z t, they are similar to each other, they are same. So they are both in common. If we get the parentheses, they will rule the parentheses at the outside. All right, I hope it's clear. And for KCL over here, we can also create a new KCL, and the same approach. We have this j omega here, and this v, and this v is same for g and c times j omega. See, c times j omega here. So absolutely same approach with the previous one. Del is del z equals to g plus c times j omega, and at the out of the parentheses we have vs over here. And all right, great to came this part. We also, I think it is our equation 4 and 5. It's not equation 4 and 5. We need one more step. Yeah, they are not the equation 1 and 5. So let's go with this one star in here, and let's demonstrate with this one with 2 stars. All right, we are going to use this one. So if we take the derivative, if we take derivative this, if we take the derivative of this equation, let's see what we end up with. All right, the derivative of the first order is the second order. In order to get second order, you have to go this square on the del, on the numerator, and z square in the denominator. And at the right side, we have R times L j omega, and for is, it is also related with z and t. Let's remember that. And it is y. It can be derivated. You can use derivative operation on it, and this is also del is del z in here. So also let's take the derivative of this one as well. I'm sorry, let's redraw it like this. So in order to make them distinguished, I'm coloring with this blue, and let's pull out this one a little bit below. So we completed this particular new KCL equation derivative, second order derivative, and now let's go with this new KCL. All right. So same idea, minus del square is divided by del z square, and it is equal to g plus cj omega del vs vz. Okay, so the new KCL and KVL equations also we got the derivative of for both of them. So let's have a close look on those two topics and see that this del is del z is equal to this one. You see, del is del z, and the right side we also have del is del z, and at the right side we have, I'm sorry, we have this whole equation. Great, and for this one, see this del vs vz also equals with del vs over del z, r plus l j omega is. And let me do like this. Great. So they both equal to each other, and it means that we can use this information in our example over here. So, but let's not forget our minus signs in here. So let's go. Minus del square vs divided by del z square equals to r plus l j omega times, what is I del is del z? It is g plus cj omega vs, but with minus. We also minus. Let's not forget it. So minus g plus cj omega times vs, and also we can just simply get rid of this two minuses over here. They can make both plus, right? Let's get rid of this one. So it is our del square vs del z square equation. So let's go for the second one. So same approach, minus del square is divided by del z square equals to g plus cj omega. But what is the equivalent of del vs del z? Let's take a look at it. It is r l j omega is, yes, but we have also this minus here. Let's not forget it. Minus r plus l j omega. I think you are going to see what is we are going to end up with. So same position, we get rid of these minuses over here, and we can also just simply delete it for the right side and for the left side as well. All right, this is our new equations. Equation number 4, number 3 and 4. Sorry, number 3 and number 4. Number 4. All right, great. So let's investigate these equations again and again. Okay, let's not get tired. All right, we have these both equations. And if I just move it down here, we can say that this is this particular one. You remember from our previous lectures this sign, and we have investigated for the quiz 1 and repetition of quiz 2 Helmholtz equation. We are aware of it. So, and if we call this R plus Lj omega G plus Cj omega, or the same thing also goes over here like this, we are getting up with an equation like this one. All right, let me do it like this. Okay. All right. For the upper equation, we can say that del square Vs divided by Vz square equals to Vs. All right, great. And also for this one, you can say that del square, I'm sorry, not Vs, this time Is divided by del Z square equals to times Is. And if we move this particular equation to the left side of the circuit, we can see that del square Vs del Z square minus Vs equals to 0. And for the right one, del square Is divided by del Z minus times Is, it is also 0. You see, we have created two different equations as well. And if you say this this one is a square, it means that also R plus Lj omega times G plus Cj omega. Right, if the square of this one is this equation, the particular, if you take a square root of it, we end up with this equation. Right. Also, we can say that it is also equals to alpha plus J beta, and it is equals to R plus Lj omega times G plus Cj omega. All right, so it is also two different equations as well. This is for equation what? Number 4, 5, equation 5, and equation 6. This is equation 7. And at last, we investigate Z0. It is equals to VO0 IO0 plus VO minus IO minus. So let's investigate this particular approach as well. And if we from the book also, you can see that for the left side and right side, we can create two different equations. One of them is r plus lj omega, or you can also do for g plus cj omega. Both of them are same. Both of them are completely same. So let's see how, right? And let's take a close look on for both of them. And for r plus lj omega, it is square root of r plus lj omega. So okay, remember that this is equivalent of this one, you see, for equation 7. And g plus cj omega. All right, great. So if we take square of both positions right here, and it means that r plus lj omega square, and for the downside we have r plus lj omega g plus cj omega. We get rid of this square root over here. And if you take a close look, that these both terms can be omitted. And you see that r plus lj omega divided by g plus cj omega. But let's remember that we take the square of this example. We got square of it. You remember? So we have to also square root of this answer, so that we can end up on same place. See, you have to pay what you get. But we square of this equation, and then we have to get rid of this debt. Let's call it debt. All right. Also, let's go for the last time for this number 2. Sorry. G plus cj omega is equal to same approach, lj omega g plus cj omega divided by g plus cj omega. And if you take square of this position again, you see that r plus lj omega g plus cj omega divided by square of g plus cj omega. Right. And we can get rid of this one and this one. And we end up with r plus lj omega divided by g plus cj omega. But we get square of it. We have to get this square by using square root. This time, yeah, we have this z0 square. But here we have z0. This one is z0 squared, but this one is z0. Okay, we have to be careful about this specific parameter. So it is done. And also, at last, let's investigate for equation number 5. Not 5, sorry. Equation number this equation, this particular equation, this new Kevyan equation. Let's remember that it was del minus del Vs divided by del z equals to, it was equal to r plus lj omega s. We know that Gs is consists of Vo plus E times minus Z and Vo minus E to del Z. You know this one, right? So, and also for Is, we have same approach. Let's write it again. Also for I0, we can use it in our example right here. So if we fill this information into this equation, we're going to see that this del V0 plus Z plus V0 minus E Z and del Z is in the denominator. So for this one, R plus Lj omega equals to, if we also get this Is like this here, E to the plus I0 E to the Z. All right, got it, great. So the derivative of this one, it is related with del Z. So we only take the derivative of Z. And we know that for E a x, and if we take derivative of this one with x, we're going to see that a times e to the ax, right? We remember from our mathematics courses from the first year and second year of the university. So if we investigate this, let's put this information somewhere here. Okay, let's not forget it. We have a minus, big minus sign over here, and VO plus. And if we take the derivative of this one, we see that like this. See? Same. Completely same approach with this one. And for the right one, we have also same approach. Right, great. For the right side, we can distribute this information on this general information. Let's not split one by one, but only go for this one. So how is it? R plus Lj omega times I-O plus E to the, we don't make derivative in here. That's because it's not written something like this. And also plus R times Lj omega I-O E to the Z in here. Alright, and this is where we get actually. And actually we can end our equations in here. Let's not go forward, but if we want to get forward, we have to use this particular information over here. This is, remember that from the instantaneous form to phasor form, we use this particular approach for Vs, or any different equation we have, e to the j omega t. And if you use it, and if we go for it, you see that this particular approach is like this: cosine omega t minus beta z plus VO0 e to the z times cosinus omega t beta z. Great. So it is where we end up our equations, actually. So let's remember what we have done. And also let's say that this is an equation number 8. Okay, let's review what we have done. It's a very long way, right? So we have our circuitry here, and we said that this is driven from a very long particular transmission line, and we only interest on the small area like this because it's a very high complicated stuff if we go for the end of the way. So in order to make this simpler, we use this particular small area, delta z. And in delta z, we have this circuitry over here, resistance, inductance, we have this conductance, and capacitance over here. And at the right side, we have this I, Z2, ZT, sorry, and we have this V, ZT, and we have this IZT. And right side, due to difference, we have this plus delta Z and V plus delta Z over here. And we derived our KVL equation, and we see that when delta Z goes to 0 for this equation, we see that del V ZT del Z is equals to R times IZT L di ZT dt for equation 1. We derived this equation. When for the KCL equation, we said that I1 equals to I2 and I3. And we remembered that also it's looking very similar to KVL equation at the end. The approach is very similar, not the answer, but the approach. And when delta Z goes to 0, we have this delta I ZT del Z. And this G V ZT plus C delta V ZT delta T. Delta T for equation number 2. And when we complete the KCL equation, we said that del over dt is j omega. We know this from our lectures. So if we use this information, we got this particular approach for the green circle. If you look at for this green circle over here, it is del over dt, it is j omega. And if you use this information, we said that this is L times j omega times IZT. And for simpler approach, we use, oh my god, what a mess is in here. What did you see? What's written here? Minus del V S divided by del Z equals to R plus L j omega IS. And same approach for the KCL. We have this minus del IS over del Z equals to G plus C j omega Vs. And if we take the derivative of these two different equations one by one, we start with the upper one. We see that del times is divided by del z appears on the question. And this appearance actually leads us to think that this equation, whole equation, can be fit into this one. But we have minus in here. We need to put that minus. And after we put that minus, we see that both equations is similar like this. And also we done this same idea for del square is. We take the derivative of is2, and we see that del vs del z is also equals to this one. Same approach as you can see. And when we fill this information with those information over here on the right side informations, we see that they are the del square vs and del z square is equals to this one, and this is equals to this one. We see that for equation 3 and 4. And at last we call this part like this, and we said that when we not take the square root, we are dealing with this one, this parameter over here. And by using this simpler equation approach, we got the equation 5 and 6. So it is very same, and it is alpha plus j beta equals to square root of this equation over here. It is actually very easy to understand until here, the equation number 7. And z square, z0 is need to be remembered by v0 plus divided by I0 plus, and v0 minus divided by I0 minus need to be remembered as like these two different approaches, number 1 approach and number 2 approach. Number 1, let's say, and we know this information, right? The highlighted information. So we have this one, and see, we have this one. So actually, we can fit this information into here in number 1 and number 2, and we see that z0 is always equals to square root of r plus lj omega divided by g plus cj omega, and at last we have go for different approach for vs and is, and vs is v0 plus and this one, and is is similar approach. And if we take the derivative of this from this particular approach, we apply this information on our equation as well, we end up with this one. All right, so this is what we have done today. We completed the transmission line equations, mostly for the introduction, and I hope it is very understandable for you. And if you have any questions, please don't hesitate to ask in the comment section. Have a great day.